Picture this: a tired scientist hunched over a computer. It's late at night and the room is dimly lit. Papers are scattered everywhere and the only sound is the soft hum of the computer. His hair is a mess. His coffee is cold. He's been at this for hours, maybe even days, trying to crack a problem that seems impossible. He's trying to solve a crazy difficult math problem. Equations fill the screen, each more complex than the last. His frustration is palpable as he stares at the seemingly insurmountable challenge. This problem is so hard it would take a regular supercomputer longer than the entire age of the universe to solve. The sheer magnitude of the calculations is mind-boggling. Meanwhile, across the room, Google's Willow chip is vibing. This isn't just any chip, it's a quantum chip, designed to handle the impossible. It's cool, it's collected, and it solves the problem in 5 minutes, while simultaneously ordering pizza and booking a vacation to Hawaii. The contrast is stark and almost surreal. The snail is not amused. It's as if the universe itself is mocking the slow pace of traditional computing. This, my friends, is the power of quantum computing, a technology that promises to revolutionize the way we solve problems, making the impossible possible. Now imagine our universe is like a bubble bath, except instead of bubbles there are universes, lots of them. Some are similar to ours, but with slight differences. Maybe in one universe, you had pizza for breakfast this morning. This is the multiverse theory in a nutshell. It's a mind-bending idea, but hey, so is quantum physics. Some scientists believe that quantum computers like Willow might be able to access these other universes. Why? Because quantum weirdness. Here's the thing about quantum computers. They cheat, but not in the way you might think. They don't use tricks or sleight of hand like a magician. Instead, they leverage the bizarre principles of quantum mechanics to perform calculations in ways that seem almost magical. See, regular computers use bits, which are like tiny switches that can be either on or off, 1 or 0. These bits are the fundamental building blocks of classical computing, and they follow the straightforward rules of binary logic. Quantum computers, on the other hand, use qubits, which are like moody teenagers. They don't just follow simple rules, they have their own complex personalities. These qubits can be 1, 0, or both at the same time. This phenomenon is known as superposition, and it's a fundamental aspect of quantum mechanics. It's called superposition, and it's weirder than a cat in a tuxedo. Imagine trying to understand a cat that's both sipping a martini and riding a roller coaster at the same time. That's the kind of weirdness we're dealing with. This both-at-once ability lets quantum computers explore many possibilities simultaneously. Instead of solving problems one step at a time, they can tackle multiple solutions all at once. It's like having a billion calculators working on the same problem at once. Imagine the computational power of billions of calculators all focused on cracking a single code or solving a complex equation. So, did Willow tap into the multiverse to solve that problem? Did it use the power of quantum computing to reach out across different realities? Maybe it just called up a few billion versions of itself in other universes for a little help. Imagine having countless versions of yourself, each with a unique perspective, all working together to find the best solution. We're not saying it did, but we're not saying it didn't either. The possibilities with quantum computing are as endless as the multiverse itself. The future is full of potential, and who knows what other mysteries quantum computers might help us unravel. Section 4. Experts say, maybe, but also, hold my beer. Some very smart people like physicist David Deutsch think Willow's speed could be evidence of the multiverse. Others are skeptical. They say there are simpler explanations and we just need to figure out how this quantum magic works. The truth is we're still in the early days of quantum computing. It's like trying to understand the internet when all we had were dial-up modems. We've got a long way to go, but it's going to be one wild ride. Section 5. The future. Quantum kittens, flying cars, and other possibilities, maybe. So what does the future hold? Will we see flying cars zipping through the skies making traffic jams a thing of the past? Or perhaps we'll have robots walking our dogs, freeing up our time for more creative pursuits. The possibilities are endless. Imagine a world where the night sky is filled with the glow of advanced technology, seamlessly integrated into our daily lives. Will quantum computers unlock the secrets of the multiverse? These powerful machines could potentially solve problems that are currently beyond our comprehension. Imagine ordering a pizza and having it delivered by a drone in minutes, Or even more fantastically, ordering pizza from alternate realities with unique toppings we've never dreamed of. Only time will tell. One thing's for sure, quantum computing has the potential to revolutionize the world. From healthcare to finance, every sector could be transformed. We're talking faster drug discovery, more powerful AI, and personalized medicine tailored to individual genetic profiles, and maybe even solutions to climate change. Imagine harnessing renewable energy sources more efficiently, reducing our carbon footprint significantly. Or, it could just lead to even more bizarre cat videos on the internet. Cats interacting with technology in ways we've never seen before. Either way, it's going to be interesting. The future is full of surprises and innovations. Stay tuned.